Hi everyone, we're going to start Unit 2. Before we begin, please try these warm-up questions. Pause the video, try the questions, and then you can go over with the answers. Pause the video and try the questions. Here are the answers for the warm-up. I wrote three names for this line. I wrote line P, and then line AB or line BA. For this one, 4x minus 7 squared, you're going to write 4x7 times 4x7. You can use the box method. So you're going to do 16x squared minus 56x plus 49. If I do 5 radical 3 squared, 5 radical 3 times 5 radical 3, 5 times 5 is 25, but square root of 3 times square root of 3 is 3. If you do that on the calculator, it's going to give you 3. So if you do square root of square root of a number, you just get that whole number inside. And 25 times 3 is 75. So we're going to start Unit 2. Today's lesson is Unit 2-1, Patterns and Inductive Reasoning. What is inductive reasoning? It is reasoning based on patterns you observe. So this is a very important definition that I need you to remember. So when I ask you what is inductive reasoning, it's reasoning based on patterns you observe. So you observe certain pattern and you make your reasoning based on that. So there are 3 stages of reasoning in geometry. First stage is look for a pattern. Look at several examples. Use diagrams and tables to help discover a pattern. Number 2, make a conjecture. A conjecture is an unproven statement based on observations. This is called inductive reasoning. So conjecture is unproven statement. Okay? And maybe you can modify over time based on your observations. Number 3 is verify the conjecture. So you have to verify by using logical reasoning to verify that the conjecture is true in all cases. So conjecture is not proven yet, and you need to verify by using logical reasoning. So these 3 stages are reasoning in geometry. So we're going to look at some examples and find patterns of the following example. We're going to identify the next 2 terms. So take a look at the first pattern. You have 10, 5, 2.5, 1.25. So what is happening is the rule is divided by 2. And the next 2 pattern will be 0.625 and 0.3125. So I just divided by 2 every time. So the pattern is divided by 2. The next example is 93, 90, 87, 84. So the rule is minus 3. So the next 2 terms are 84 minus 3, which is 81, 81 minus 3, which is 78. Next pattern is 4, 16, 64, and 256. You're going to multiply 4 each term. So 256 times 4 is 1024. 1024 times 4 is 4096. There is a famous pattern called Fibonacci pattern Fibonacci sequence. It's 1, 2, 3, 5, 8. So this actually is a really famous pattern. So 1 starts with 1, and 1 plus 2 is 3, and then 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21. So what you do is you add first two numbers to get the next, first two numbers to get the next, first two numbers to get the next. It's called Fibonacci sequence. It's a very famous pattern. Let's take a look at visual examples. Find the pattern in the following examples, then identify the next two terms. Right here, you have a triangle in a circle. Now you have a square in a circle, and then now you have a pentagon. So what is happening to each circle? We're going to draw the next two patterns. So you're adding one side each circle, right, inside the circle. So you're going to have a 1, 2, 3, 4, 5, 6 hexagon here. And then you're going to have another one. You're going to do 7 side, which is septagon here. So you can draw these two circles after these two. So those are the two terms. So let's take a look at this shape. So you have a square, you have a like a diamond inside the square, or a rectangle rather, rectangle inside it, and then you have another rectangle here inside, and then you're going to do another and then do another. So let's draw a pattern of two terms for these two. So go ahead and pause the video and draw the next two terms. So please remember, not all conjectures are true. Conjecture is unproven statement based on your inductive reasoning, based on your observation. So inductive reasoning is your observation. You observe a pattern and you make a prediction. That's conjecture. But not all conjectures are true. You should test your conjecture multiple times to make sure it is true. To prove a conjecture is false, you only need one counter example. So that's a new vocab also. Counter example. Counter example is an example that shows a conjecture is incorrect or false. So after you use observation, which is called inductive reasoning, and you see that conjectures are false, you can counter that and prove that it's wrong by using one counter example that shows that it is false. And you have to explain, basically you explain with an example why this conjecture, this prediction is incorrect. So that's called counter example. So we got a lot of new vocabs here. Inductive reasoning, which is observation, looking at pattern, making observations. You have a conjecture, which is making prediction and a statement based on your inductive reasoning observation. And counter example, which means when conjecture is false, you use an example to show that it is not true. So let's look at an example here. Example, show the conjecture is false by finding a counter example. Conjecture, for all real numbers x, the expression x squared is greater than or equal to x. This is false. How come it's a false? Can you give me a counter example for this? I want you to pause the video and think about this and see if you can give me an example why it's false. Pause the video and write your reasoning. So the reasoning, the counter example for this is, what if x is a fraction? What if x is greater than 0, less than 1? Is x squared going to be greater than or equal to x? For example, if x is 1 over 2, 1 over 2 squared is 1/4. That's smaller than 1 over 2. So you can give an example like that. That what if, if x is between 0 and 1, and if x is 1 over 2, or a fraction, if you square that, that's not going to be greater than or equal to x. That's going to be less than x. So that's an example, counter example. So let's try more examples. Give a counterexample for each. If an animal is green, it is a frog. Is this true or false? And give me a counterexample. You can connect any 3 points to form a triangle. Is this true or false? Give me a counterexample. If it is Monday, students are in school. Is this true or false? Give me a counterexample. Go ahead and pause the video and try answering these 3 questions or examples. Pause the video. So when you give counterexamples, they're all false, right? If an animal is green, it's a frog? Not all the time. That's false. So what will be my counterexample? Iguana. Iguana is green, but it's still an animal, and it's not a frog. So you can give another example of an animal that is green but not a frog. You can connect any 3 points to form a triangle. False. Here you can have 3 collinear points, right? So you can also have collinear points and not form a triangle. If it is Monday, students are in school. False. It could be Monday can be a snow day, and then we don't have school. Then students are not in school. So not every Monday students are in school. You can have a Monday holiday. You can have Monday Columbus Day. You can have Martin Luther King's Day. That's Monday. You're not always in school on Mondays, so that's false. You can have any snow day or Monday holidays. So that will be an example of counterexample. Thank you for watching the video. We'll do more practice in class.